This is a quick demonstration of the vSphere 5 VAAI or vStorage APIs for array integration enhancements performed on an EMC VNX storage subsystem and demonstrated at VMworld 2011. The first demonstration here is around one of the new block storage assists that's in vSphere 5, specifically a thin provision storage reclaim. What we've got here is we've got a web server virtual machine, and if you take a look, you can see that this virtual machine is consuming roughly around 70 gigs of data. Let's take a look at it first at the underlying storage layer. This is EMC vSphere, which is used on EMC VNX storage arrays. It's tightly coupled with vCenter and integrated, but one additional thing that we want to point out here is that we've got a large pool, 8 terabytes, of which roughly around 70 gigabytes is currently consumed by this individual VM. And if you take a look at it, the vSphere 5 and vCenter layer, you can see that likewise this web server is consuming roughly around 70 gigabytes. You can see that you've got a matching view at the underlying storage layer and at the vCenter layer. What we're going to do here is in this particular web server, we're going to open up the snapshot tree and via Snapshot Manager. And what you'll see is that earlier on we had created the virtual machine, at which point very little space was used because it was using thin at the VMware and underlying storage layer. But then we did a DD to populate the virtual machine with boatloads of data. So what we're going to do is we're going to revert the snapshot and then delete the snapshot and see what happens. This process of reverting the snapshot, in previous versions of vSphere, if you were using thin devices and thin at the VMware layer, would release the space at the VMFS layer, but would not release the underlying space at the storage subsystem. So now as we delete the snapshot, you'll notice that at the vCenter layer, we've returned back to a much less space being consumed in VMFS 5. Let's take a look at what it looks like within Unisphere on the underlying thinly provisioned storage device itself. So here you can see at the VMware layer, only 2 gigs is now in use versus the 70 gigs that was there before. And if you take a look at the underlying storage layer at Unisphere, you can see that in that thin pool, on that thin device, we're now down significantly in amount of consumed capacity. You'll notice that it says 8 gigabytes and now 6 gigabytes. This is a little bit of an asynchronous process of returning things to the pool. But simple, easy, automated, and efficient. One of the advantages of the new thin provision hardware assist. The next example that we're going to look at is the NAS hardware assist that appeared in vSphere 5. For NFS Full Copy. This is used when you clone a virtual machine. It's a rough analog to the VAAI command that was in vSphere 4.1 for block devices, a hardware accelerated copy. One important difference is it's not used during storage vMotion operations and cloning operations, but only during cloning operations. So here what we're going to do is we're going to create a clone, and we're going to do it in a case where the hardware assist is not enabled. So that you can see a before and an after effect. What occurs here, and this has been the case for a long time with NFS-based data stores with VMware, is that in effect we're doing a full file copy. The file's being read from the NFS server, in this case the VNX array, into the ESX host and then being written back out again, which of course is reflected in a very high amount of bandwidth consumed on the VMK NICs that are supporting the NFS export. You'd see this on the storage subsystem as well, of course, because the data is flowing in and out of the NFS server into the ESX host and back. So this can obviously be done a lot more efficiently, and that's what the new NFS Full Copy command does. So if we take a look at the contrasted example where we enable the command, let's see what that looks like. This time we'll do the same operation, but we'll be doing it against a data store that supports the NFS Full Copy command. So if we take a look at this data store, when we scroll over to the right, you can see that hardware acceleration is supported. It'll be a pretty obvious compare and contrast. So let's create, once again, a clone of this operation. This also applies for deployed from template, but once again, on the NFS use case, unlike the block use case, with VMFS volumes, it doesn't apply during storage vMotion operations. As this operation, we select the target data store. If we open up both the array view of things and the ESX host view of things, it's quite an apparent contrast. So what's occurring here is that we're passing the request to create a file copy directly to the EMC VNX array, which can create file-level copies and file-level snapshots internally. And you can see that the amount of traffic that's on the VMK NIC is virtually nothing. Likewise, if we take a look at the VNX itself, and we take a look, you'll notice that there's almost no traffic in and out on the interfaces that support the NFS export. You will notice that there is a large amount of traffic. The deval reads and writes is the actual back-end array copying the file. And NFS Full Copy requires that you do a full copy of the file, and therefore whether or not the task is longer or shorter, your mileage will vary. But what will not vary is that the amount of network traffic used, the load on the ESX host, the load on the network, the load on the actual storage subsystem itself from the processing of the file system IOs is lower. The actual back-end file copy must still occur. Again, this is just 2 of the 4 new VAAI commands in vSphere 5. NFS Full Copy, NFS Space Reservation on VMFS block volumes, a thin provision stun, and thin provision reclaim. Fully supported by EMC VNX and on Vmax arrays.